Hello students, now we will discuss some revision questions for 5 marks for the second PUC annual examination mathematics. Now among the 5 marks questions, you will get one question sure from the first chapter, and this year in the reduced syllabus you will not have the invertible function, therefore there will be definitely a bijective function problem, and this one of the important problem. How to solve this one? It's a sure question type of questions. You will get one model. Any question comes, the method is same, only the functions will change. You have to verify it. Now you can see here the question here is, let A and B two sets are given, real number minus 3 and real number minus 1. Considering a function f from a to b defined by f of x equal to x minus 2 divided by x minus 3 is f11 and on to. See, very easy to score. You can use the technique. Okay, same technique will be used for all the questions and you can easily score this one. Now we'll see first, see, is f11 not the function, and if it is yes, then we have to, is yes or no, we have to justify our answer. Yes. Now I'll see, we'll check it first. Let x1 comma x2 belongs to a, we take. Okay, now such that I'll take f of x1 is equal to f of x2. It means we know the function f of x1, you take it becomes x1 minus 2 divided by x1 minus 3. See the function, it is here. We are in the place of x, I am writing x1 left side, and right side I am writing x2. x2 minus 2 divided by x2 minus 3. Now I am trying to solve this one. Now if you cross multiply here, you can see you will get x1 x2 minus 2 x2 minus 3x1 plus 6, that is plus minus 3 into minus 2 is plus 6. Now we will cross multiply here. It is x1 x2 minus 2x1 minus 3x2 minus 3 into minus 2 is plus 6. Now because they are in opposite sides, see x1 x2 get cancels, plus 6 same cancel because same value and same sign. Now we have minus 2x2 here, and here minus 3 x2. I will bring this one here. Now this is minus 2x1 and minus 3x1. I will take here. This is minus 3x1. I will keep here. This minus 2x1 bring it to right side. That is plus 2x1. This is equal to minus 3x2 is already here. This x2 I am going to right side, becomes plus 2x2. Now you can see when you simplify this one, it becomes minus x1. This is equal to minus x2. Minus minus get cancels. This implies x1 equal to x2. See, we have started with f of x1 equal to x2 and we got x1 equal to x2. Therefore, f is 1 function. We got justification for this. Now we have to check it for onto. Now to check it for onto, we'll see here. I'll take here after. Let y belongs to b defined by f of x is equal to y equal to x minus 2 divided by x minus 3. When you simplify this one, it becomes this one, xy minus 3y is equal to x minus 2, because here we have 1 to cross multiply. And now if you simplify this one, xy minus x is equal to, here minus 3y goes to right side, becomes 3y minus 2. Now if you take x common in this case, or I'll finish it here. If you take x common, it becomes y minus 1 is equal to 3y minus 2, or x is equal to 3y minus 2 divided by y minus 1. Now for every y belong to b defined by this function, we have got x here. Therefore f of x is equal to f of 3y minus 2 divided by y minus 1. Now we can substitute in this function. If you get f of x equal to y, then it is onto. It means 3y minus 2 whole by this divided by y minus 1 minus 2. Remember, I am substituting in the place of x in this function, divided by 3y minus 2 divided by y minus 1 minus 3. This is like this here. Now when you cross multiply, 3y minus 2 minus 2y plus 2, when you cross multiply this one, divided by y minus 1 whole divided by, now if you cross multiply this one, this is 3y minus 2. If you cross multiply, it becomes minus 3y plus 3 whole divided by y minus 1. Now this y minus 1 get cancels. Now you can see here, this minus 2 plus 2 get cancels. This plus 3y minus 3y get cancels. You will get here plus 3y minus 2y is y, and minus 2 plus 3 is 1. So this means we got f of x is equal to y. So hence we have f is onto function. So now we got answer for the question. F is f1 and onto. Now we can conclude is f is 1 1 and onto. Okay, we have completed our justification. In case if they ask you whether it is a bijective function, so we can say f is also a bijective function. So remember students, this is a very easy question. You can easily score the 5 marks in this. Don't leave, it is common method for all, only the function will change. To show it is 1 1, we take f x1 x2 belonging to the first set, then we take f of x1 equal to x2, so that should implies we should get x1 equal to x2. Okay, just see every element in set A as distinct images in set B. That by looking at the question itself we can see, and most of the time if for a 5 marks question they can't give a function which is not a 1 1, because for 5 marks we face 1 1, it can't be, and then it may be onto or may not be onto, it will not become bijective, so they will not get a 5 marks question in such case. So definitely they will give most of the time which is a bijective function. Then to find onto, like every element in set A has a unique image in set B, so every element in set B should have a distinct image in set A. Therefore, if you prove for every y belong to B, f of x equal to y, then it is an onto function. Once it is 1 1 onto, then it becomes a bijective function. This completes this question. Now in each chapter I will do one important question, so that when you get for a test for tomorrow, you will be able to do any similar question like this. Okay. If you have any doubts, you can call back to me or any other maths faculty of our college. Now we will discuss the second question in our revision class, because in second chapter inverse trigonometry we don't have a 5 marks question. So we have come to the third chapter matrices. So we will get a 5 marks question from this also, and definitely it will be on the multiplication of the matrices, or like this distribution property checking. Okay. Now this very easy chapter, and most of the students should attempt this one. Okay. And they used to attempt and they will attempt. Okay, so it's a very easy question, but you have to be very careful when you are doing multiplication. Addition generally you don't do mistake, but multiplication you may have the chances of doing. So little carefully and slowly if you do, you can score it. And one more advantage is we have easy method to verify this one. Okay, so LHS should be equal to RHS, and only 3 or 4 questions are there which will suit for 5 marks. So one of this will be there for your annual examinations, and you have already written many tests on this. You have been scoring. I hope you will continue that scoring marks in this chapter. Now first we will take LHS. If they ask you to calculate also, you will do the same thing and then you will take LHS. Okay, now first case. LHS is A plus B into C. Now first let us do A plus B. A plus B is 0 6 7 minus 6 0 8 7 minus 8 0 plus 0 1 1 1 0 2 1 2 0. We have just copied what is it, and C is 2 minus 2 3. This just we have copied from the question. Now when you are adding this one, you can see to add two matrices they should be of same order. Then we add the corresponding elements. Both are 3 cross 3 matrices. Now corresponding elements we are adding here. 0 plus 0 0, 6 plus 1 7, 7 plus 1, 8. Minus 6 plus 1, minus 5. If you have any confusion when you are taking sign, addition, subtraction, you use calculator. So calculator knows Bodemus rule. Don't worry about that, okay? But you should know the rules, okay? So when bigger number is minus, it is one number is plus or minus, bigger number is minus, then the sign will be minus. 8 plus 2, sorry, 0 plus 0 is 0, 8 plus 2 is 10. Now 7 plus 1, 8, minus 8 plus 2 is minus 6, 0 plus 0 is 0. Now into, see that is 2 minus 2, 3. Now multiplication, this is very important part. See, when there is no square, this one, about the multiplication of the matrices properties should be used here. Here we have the first matrix of order 3 cross 3 and second matrix of order 3 cross 1. Therefore, see, number of columns here is 3 and number of rows in second matrix is, therefore this can be multiplied. Resultant will be 3 cross 1 matrices. This should be very important, because many times when you confuse, you will write a different order one, instead of adding you will write it as it is. Now we will see. First row to first column, 0 into 2 is 0, 7 into minus 2 is minus 14, 8 into 3 is 24. By default it is always addition. Because of confusion, you should not leave this one. First row, when you multiply to first column, you will get the first element only, because there is no second column, so number of columns will be only 1. Now when you do to second one, it is minus 5 into 2 is minus 10, 0 into minus 2 is 0, 10 into 3 is 30. Similarly, now you can see 8 into 2, 16, minus 6 into minus 2 is plus 12, 0 into 3 is 3. Sorry, 0 into 3 is 0. Now when you see this part completing, this is A plus B into C, that is LHS part, you can see you will get this one. Minus 14 plus 24 is 10, plus 10 because bigger number is greater, and so bigger number is plus. Then now minus 10 plus 0 plus 30 is again plus 20, again 16 plus 12 plus 0 is 28. So this we can call it as equation 1. Now we shall do the RHS for verification. When you do RHS for verification, you can see it is AC plus BC. So first we can find AC. So A, first matrix, that is 0, 6, 7, minus 6, 0, 8, 7, minus 8, 0. Into C, C is 2, minus 2, 3. Now we can see it is 3 cross 3 matrix. And this is 3 cross 1. These two are equal, so resultant matrix should be 3 cross 1. This is C plus BC. Now we have AC into BC. Now we know 3 cross 3 matrix and is 3 cross 1 matrix. The resultant will be 3 cross 1 matrix. Now we will multiply the first row to the first column. So 0 into 2 is 0. 6 into minus 2 is minus 12. 7 into 3 is 21. Similarly, minus 6 into 2 is minus 12, plus 0, plus 8 into 3 is 24. Now 7 into 2, 14, minus 8 into minus 2 is plus 16, 0 into 3 is 0. So we get AC equal to minus 12 plus 21 is 9, minus 12 plus 24 is plus 12, 16 plus 14 is 30. Now similarly we will find out BC. So B matrix is 0, 1, 1, 1, 0, 2, 1, 2, 0. C matrix is 2, minus 2, 3. So same result, it is a 3 cross 1 matrix we will get here order. So 0 into 2, 0, first row to first column. 1 into minus 2 is minus 2, 1 into 3 is plus 3. Now 1 into 2 is 2, 0 into minus 2 is 0, 2 into 3 is 6. Again 1 into 2 is 2, 2 into minus 2 is minus 4, 0 into 3 is plus 0. So it is 1, 8, minus 2. So we got both AC as well as BC. Now we will find out AC plus BC, which is equal to, AC is 9, 12, 30, and BC is 1, 8 minus 2, which is equal to 10, 20 and 28. So we got AC plus BC, which is equal to 10, 20, 28. I call this as equation 2. Now compare with equation 1, both are same. Therefore, from equation 1 and 2, LHS equal to RHS. Hence, verified. So this is very easy and very important question, and you can score the marks in this question very easily. Okay, so don't miss this type of question from this chapter for 5 marks. Next, we shall move to the next question. Friends, this is the question from the chapter Determinants, solving the system of equations by matrix method. So we can solve this one the following method. This is also one definite question for 5 marks, and we can score it easily. It takes some time, but it's easy to score, and also we can verify. So we can start like this. The given system of equations can be written as Ax is equal to B, or X is equal to A inverse into B. Now let A equal to all the coordinates of X. Second equation we have no X, therefore 0, then again 1. Then all coefficients of Y, that is 1, 1 and minus 2. Now all coefficients of Z, that is 1, 3 and 1. Now X is the variables here, that is X, Y and Z, because if you multiply these two we get the LHS of the given system of equation. Now B is, what is the right hand side, that is 6, 11 and 0. Once we get this one, see, first we have to find the determinant of the given matrix A. That is what we have taken as matrix A. Now if this is non-zero, then we get A inverse exist and the solution also will be exist. Otherwise it may be a singular matrix. Now when you are finding determinant, we can expand from anywhere, but we can take from first row, plus minus plus. It's 1 into, leaving this column and row, 1 into 1, 1, minus 2 into 3 is minus 6, therefore this becomes plus 6. Minus 1 into, leaving this row and this column, 0 into 1 is 0, 1 into 3 is 3, therefore 0 minus 3, plus 1 into, leaving this column and row, 0 minus 1. Now this becomes 1 into 7 minus 1 into minus 3 plus 1 into minus 1. That is determinant of A is equal to 7 minus 1 minus 3 is plus 3, plus 1 minus 1 is minus 1, which is equal to, or we can say determinant of A equal to 7 plus 3 is 10, 10 minus 1 is 9. So we get determinant of A equal to 9. This is very, very important. So because determinant of A is non-zero, so solution exists and it is a unique solution. Now we have to find the cofactors. See here, when I was finding the determinant itself, I expanded from first row. So I have found the coordinates of cofactors of the first 3 elements. So they are nothing but, which is the bracket, but without z, means I have the minus here. So if I just apply the sign, I will get the cofactors. So for first one it is plus sign, and the element, the minor is 7, because when you leave this row and column, what we get is 7. This is already there, plus into 7 is plus 7. Then second cofactor A12 is equal to minus of, here it is minus 3, therefore it becomes plus 3. Then A13 is plus C, plus minus we can go. So I have taken here, minor is minus 1, so plus 1 into minus 1 is equal to minus 1. Now I got A11, A12 and A13. Now I have to find A21. See, after plus again it is minus. Now this is A12 element, Now leaving this column and this row, I have these 4 elements. So 1 into 1 is 1, minus 2 into 1 is minus 2. Already I have minus into minus, it is plus 2. So minus into 3 is minus 3. Again A22 is equal to plus. Again this is the element. So leaving this column and this row, we have these two elements and these two elements. 1 minus of 1. 1 minus of 1 is 0, irrespective of whether it is multiplied by plus or minus. Then we have A23. See here very carefully, I am writing the cofactors of each row in the form of column, because to find adjoint A, I have to transpose the cofactor matrix. So I am taking in terms of column, so it will be easy for me to write the adjoint matrix. Now A23, this is the element A23. Now leaving this column and this row, it is these two and these two elements. 1 into minus 2 is minus 2, minus of 1 into 1 is 1. So minus 2 minus 1 is minus 3, outside we have minus, therefore it becomes plus 3. Now I got second row cofactors. Now I will go for cofactors of third row, A31. After minus it is plus. Leaving this column and this row, it is 3 minus 1. Very carefully you should do this one. Always it's principal diagonal minus non-principal diagonal. Here if you do it opposite way, you will get the ranges. A32 is equal to minus of, leaving this column and this row, 1 into 3 is 3, 0 into 1 is 0. It is 3 minus 0. So outside we have minus, therefore it is minus 3. Even if you miss one cofactor, your answer will not be correct. So plus, after plus it is minus, again after minus it is plus. So last cofactor, leaving this 2, 1 minus 0. That is again it is 1. Now we want to find adjoint of A. Adjoint of A is equal to cofactor matrix transpose. Also A inverse is equal to 1 by determinant of A into adjoint of A. So directly now I am going to take here, what I am going to take here is, we know this X is equal to A inverse into B. Now I have the A inverse formula, that is 1 by determinant into adjoint A. Adjoint A is cofactor matrix determinant. So I will take here 1 by determinant of A. That is determinant of A is 9 into A inverse. We have adjoint of A. For adjoint A, we have to write the cofactor matrix transpose. These are the elements of cofactors of first row. I am going to write this in terms of first column, so that I get the transpose. That is 7, 3 and minus 1. 7, 3 and minus 1. Next we have second row. In the terms of column it becomes minus 3, 0 and plus 3. Then it is third row. I will write in terms of column 2, minus 3 and 1. Now into B. B we have written in the beginning. It is 6, 11 and 0. So I am multiplying a 3 cross 3 matrix with a 3 cross 1 matrix. My resultant matrix will be 3 cross 1 matrix. Therefore I get X is equal to 1 by 9 into first row to first column. See carefully, 3 into 7 into 6, 42, minus 3 into 11, minus 33, 2 into 0 is 0. Then 3 into 6, 18, 0 into 3, 0, minus 3 into 0 again, 0. Here it is minus 1, minus 1 into 6 is minus 6, 3 into 11 is 33, 1 into 0 is 0, which is equal to 1 by 9 into 42 minus 33. So 12 minus 3 is 9, 3 minus 3 is 0. This is 18. This is minus 6 means it is 27. So X means we know it is X, Y, Z, which is equal to, if you divide by 9, it is 1 time, 2 times and 3 times. So we get, therefore X is equal to 1, Y is equal to 2 and Z is equal to 3. By this we complete the solution. If you want, we can also verify here by substituting. In the easiest one you can see Here this is for just checking. Y plus 3z is equal to, and we see y is here 2 plus 3 into z, we know it is 3. We get 9 plus 2 11, so it is verified. So this is how we find the solution for the system of equations in determinants chapter. This is also very easy question, you can find it. Now we shall go for next 5 marks question, which is important. The question from application of derivatives. Okay, before this you used to get one more question from 5.7 second order derivative. So I choose to this one first, and I will do that one more question on that model also, because usually you are good at that. I thought of doing this one. Okay, now here you can see the question. The length x of a rectangle is decreasing at the rate of 5 cm per minute. Means what they given is decreasing, means it is negative. So dx by dt is given as minus 5 centimeter per minute. Next, and width y. So here if you imagine a rectangle, so length is given as x, width is y. So width they are given dy by dx, increasing, so positive. It is 4 centimeters per minute. Now at they are given at x is equal to 8 centimeter and y is equal to 6 centimeter. We have to find two things: the rate of change of perimeter. In first case perimeter, if I take as p, dp by dt. Second one, area. If I take A as area, it is dA by dt. These two questions I have to find. Now first thing, we'll go first. So first part, we have to find the perimeter. So let P be the perimeter of the rectangle. Okay students, then we know the formula. It is 2 times length plus 2 times width, because we have both lengths equal and both widths equal. So it is 2 times x plus y. Now if we differentiate this with respect to time, so dp by dt is equal to 2 into dx by dt plus dy by dt. So it will be equal to dp by dt is equal to 2 times dx by dt, that is minus 5, plus dy by dt, it is plus 4. So we'll get 2 into minus 1. Therefore dp by dt is equal to minus 2 centimeters per minute. So the rate of change of perimeter is, so perimeter is decreasing at the rate of 2 centimeters per minute. Now we will come to the second part, that is area. Okay, let A be the area of rectangle. Now area of the rectangle is given by length into width. Here length is given x, width is y, so it is x into y. Now if you differentiate this with respect to time, that is t, then dA by dt, it is product rule, that is dx by dt into y plus x into dy by dt, which is equal to dx by dt we know, and also we know x and y, they are given at x equal to 8 and y is equal to 5. Here we did not get that opportunity to substitute, so we did not do, but here we have to use that one. So also we can see now at x is equal to 8 and y is equal to 6 centimeters, dA by dt is equal to dx by dt is minus 5 into y is 6 plus x is 8, dy by dt is plus 4. So it is minus 30 plus 8 4s are 32, which is equal to plus 2. It means area is increasing at the rate of 2 centimeters per minute. It means area of rectangle is increasing at the rate of 2 centimeters per minute. Like this, students, we can find out, and this very easy questions, and a little bit you have to understand the concept. Working time is very less, and time taken and was scored, if you compare, in very less time you can score very good marks in this. So don't miss this one. And we have very few problems because this time they told only in 2-dimensional one, they will not give in 3-dimensional one. Therefore this type of question you can easily score the marks in annual examination. We shall move to the next question. And question, and you will get in differentiation 1 5 marks question. So it is actually before the application of derivatives. It is from differentiation, and this time we have very limited questions in this. You can easily score the marks in this. Don't miss in this. Okay, so very simple. See the right hand side, we have second differential. Y1 and y2 represents first derivative and second derivative. X square and x we have to multiply. Y is given here. Y we already have here, so we can differentiate this y with respect to x. So y1 is first order derivative, that is 5 times cos differentiation is minus of sine, right, as it is chain rule, log x. Then now differentiate log x. Log x will be 1 by x plus 7 constant keep as it is. Sine differentiation is cos chain rule, therefore keep log as it is with respect to log x. Then for log x it is 1 by x. Now you can just cross multiply x on this side, or multiplying x on both sides, we get x y1 is equal to minus 5 sine of log x plus 7 cos of log x. So let it be as it is. Now next, because we want second derivative also, differentiate this again with respect to x. Now we get this one in UV method, that is product rule. Differentiation of first plus second plus first into differentiation of second one, UV. So product rule I am going to use. So differentiation of x is 1, difference and write y1 as it is, plus x we write as it is. Differentiation of y1 is y2, which is equal to, again when you come to right side, it is minus 5 is constant keep as it is. Difference sine is cos, write cos log x as it is. Then according to chain rule, for log x the differentiation is 1 by x. Again plus 7 right as it is. For cos the differentiation is minus sine, write log x as it is. For log x again according to chain rule, again it is 1 by x. Now multiply both sides by x. We get x y1 plus x square y2 is equal to, because this x we are multiplying this side, so here we have minus, here also we have minus, take minus common. So we get 5 cos of log x, because we are taking minus here and here also minus outside, so this will remain as plus 7 sine of log x. Now compare with the given equation y, so it is exactly same. So we can just rearrange and write this one. I can write this one as x square y2 plus x y1 is equal to minus of y, or I can write x square y2 plus x y1 minus y comes this side, becomes plus y equal to 0. Therefore LHS equal to RHS. So shown. So this is how we can complete this and score 5 marks very easily. Remember, for first differentiation you will get 1 mark, second differentiation you will learn 1 mark, then simplifying and writing. So depending on each question, sometimes techniques will change, but the scoring is very easy in this. So if you practice it well, you can score very well. Okay. See, you don't need to write 6 questions, all the 5 in first part you can write it very easily. Then you will get 1 mark from continuity also, that one 4 marks question, 10 marks that you can do. So easily you are getting 25 marks from this part itself. Okay. So next we'll do the second part questions.